Hello again, physicists. Today's topic for you is distance versus displacement and speed versus velocity. This is essentially going to be a mop-up video where we go back and maybe ideas that we didn't explicitly talk about in the beginning, I bring up now for the benefit of our future in AP Physics. So to begin, I'm going to start with a little bit of vocabulary for you. Two terms, and these terms are actually going to be the names for the two types of quantities we can have in physics. The first being a scalar, and this will be a quantity with only magnitude, and another word for magnitude would be size. Essentially just a number, how large or small the quantity is. The second category, and one that we will have to pay close attention to throughout the year, is the vector. And vector is a quantity where not only does it have a magnitude, but there is also direction associated with that quantity. I've taken the liberty to already sort the main quantities that we've discussed thus far in the year into scalar and vector categories. So things like displacement and velocity and acceleration, these are all vectors. They have a direction associated with them. I could say I displaced myself, 10 meters in the positive x direction. I could say my current velocity is 55 meters northwest, or I could say I am accelerating in the negative y direction. Whereas with scalars, these are things where direction just does not make too much sense for us. Things like time will be a scalar. And then two things that maybe you've heard before this class but are different from displacement and velocity. I'm talking about distance and speed. So here we're going to really compare what distance is versus what displacement is. We already know that displacement is the change in position for an object. Well, distance is something physically different. Distance is the actual path an object travels, accounting for every single meter of the journey. In my little diagram here, Frodo Baggins is on an intrepid journey to climb the top of Mount Doom. He's going to start right here at the blue X, so that is his starting position. And the red dotted path that I am tracing over right now, this represents the journey he took to get to the top of Mount Doom. This path represents Frodo Baggins' actual distance, because we're accounting for every twist, every turn, every meter of the trip. Whereas the black arrow is representing Frodo Baggins' displacement, because this is the straight line change in position for Mr. Baggins from the blue X to the red X. So distance versus displacement. The differences in speed and velocity stem from the differences between distance and displacement. Speed is determined by definition by finding the change in an object's distance, or how much distance it traveled, divided by a certain time interval. While velocity, we already know, is the change in position, or the displacement of the object, divided by time. So the difference between distance and displacement leads to the difference between speed and velocity. And again, velocity is a vector. That means technically we should be specifying direction when we talk about velocity, whereas we do not need to do that when we talk about speed. So the last thing for today is I'm just going to go back to the track problem from our average velocity video. And in there, I told you there's a case where you could theoretically move around the track but have zero velocity due to the fact that you start and finish at the same point. Therefore, you have no change in position. Therefore, you have no velocity. Well, you would still have an average speed in this case, because with speed, you are actually accounting for the distance that you travel all the way around. So if I did 1 lap around the track, I would have covered some distance, and therefore I would have a non-zero speed, even though my velocity would be 0 in that case. So again, this reiterates the point of how the difference between distance and displacement can lead to the difference between speed and velocity. That's all I have for you today. Until next time, physicists, until next time.